Chapter 12, Rational Functions. We'll first start with some vocabulary. A monomial, mon meaning one, is a single term. It can be made out of coefficients or variables. It can also be made out of coefficients and variables. There cannot be any fractions or decimals, no square roots. You cannot have negative exponents. You cannot have x in the exponent position, and you cannot have an absolute value in order for it to be a monomial. So here's an example of a monomial. 3x squared. That's a monomial. It's one term. If I were to put a plus sign in and another term, I would now have a binomial, but a monomial is just that first term. Moving on. A polynomial is a sum or difference of monomials. I just gave you an example of a binomial. A binomial is a polynomial. A monomial is a polynomial. A polynomial is a bunch of terms that are each monomials that are connected with addition or subtraction. A rational function is a function where the numerator and the denominator are both polynomials. And the key here is that the denominator cannot equal 0. 0 does some interesting things when we put it in the denominator, which we will discover in this unit. You're going to do a little bit of review on domain. So in this independent practice, I want you to write the domain of the functions. So the domain is any x value that will work. And I want you to write each in interval notation, explaining your answer. So in order to explain your answer, you could show me your work or tell me why you're answering a certain way. A graph might be a good explanation of your answer. I'm going to do this investigation with you right now. This is a rational function. The numerator is 1 and the denominator is x. We're going to state the domain and range using interval notation. In order to do that, let's make a graph. So open up Desmos. You are starting a new blank graph, and we'll say f of x equals 1 over x. And there's our graph. State the domain and range in interval notation. Okay, so let's look at this graph. It appears as though x goes on and on in the negative direction for a while, at least to negative 10, and the positive at 10. So let's zoom out, see what happens. It just keeps going. Okay, so the domain goes from infinity to infinity, but there's an exception. There's a value for x that cannot go into the domain, and that is the value that would cause the domain to be 0, and that value is x cannot equal 0. So our domain is from negative infinity to infinity, not including 0. And then our range, you'll see that it goes down and up forever. It is also from negative infinity to infinity, but not including 0. There's no way for the equation to output a 0. We'll explore that more here in a moment. State the domain and range in interval notation. So the domain is from negative infinity to 0, union with 0 to infinity. And the range is the same thing. Make our table using Desmos that goes from negative 3 to 3, counting by ones, and plot and label the points on the graph provided. Okay, so let's see if we can do that. Head on back to Desmos, and we want to go from negative 3 to 3. All right, so what I did there was I went to this little gear and I selected convert to table. And right now it's going from -2 to 2. And I want it to go from -3 to 3. So if I go down below, I can type in -3. And the order doesn't matter. I'm going to type in 3 as well. And the points that I had just typed in, or that I had asked to appear on the table, are now appearing on the graph. Good so far. Let's change our window just so we're not going out to -15. There we go. Plot and label the points on the graph provided. Okay, so we'll need our x-axis and we'll need our y-axis. And those points were -2, -0.5, and we can probably do +2 and +0.5, -2, -0.5, +2, +0.5. Then we had 1, 1, and -1, -1. And we had 3, 1/3, and -3, -1/3. Okay. And I said things like label your scale so I know what you're counting by. So I'm going to do 2. And I'll put this out here at 5. All right, good enough. Add x values to the table between -1 and 0. These will be fractions and decimals. See what we can do between -1 and 0. So what's a good value between -1 and 0? Let's do -0.5. Okay. -0.5 is 2. Let's do -1/4. -1/4. Okay, became 4. What about -1/10? That's 10. All right. Now, what I want you to try is we're going to put in a number really, really, really close to 0. So we'll put a -0.0000001. Okay, and this number here says -1 times 10 to the 7th, and that is scientific notation. It's basically 1 with 7 zeros behind it, which is a large number. That's 10 million, I believe. There we go. There's a million. So, all right. So you can see as x is getting closer and closer and closer to 0, the y is growing very, very quickly. It's growing. It's approaching infinity. What happens to f of x as you divide by smaller and smaller values of x? I'm going to say the y values grow quicker and get closer to infinity. In this case, -infinity. We were finding 1/2 was 2, and 1/4 was 4. And then it got real, as I put in a number close to 0, it shot off down here to 1 million, and 1 million's really just not going to fit on my graph, so I'm going to just put an arrow for now. Okay, and put arrows here. It's not going to cross 0, but it'll get real close to 0. Add asymptotes to the graph. What is an asymptote? It's fun to spell. It's got a lot of consonants there in the middle, a silent P. It's craziness. An asymptote is the line that your graph approaches. It can be horizontal or vertical, and basically your graph is getting really, 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 really close to this line as you're approaching infinity, but it never crosses that line. It's indicated by a dashed line to show its exact location and that it's really not a part of the curve. So in this image here, it'd be great if you could dash this. That is a horizontal asymptote, and this one, you can dash it, it is a vertical asymptote. Now, our graph up above, the horizontal and vertical asymptote are also the X and Y axes, which is a little unfortunate for our image. I don't know if I can change the color of this pen. Let me see. I put a dot down. Not helpful. Put another dot down. I don't need any more dots. Stop with the dots. I've broken it. Well, I'm putting dashes in. Don't know if that's the best way. You all should be working with pencils. And now I don't think my dashes go vertical. I'm struggling here. Okay. You get the idea. I'm gonna try one more thing before I give up. I'm still writing in red. Okay, well, dashed lines to indicate the asymptotes. The next thing that we're going to do will be done in class, and that'll be the group work. I've given you 2 functions. I want you to identify the domain for each of them, writing the domain in interval notation, and graph them. All right, well, let's see how this video turned out. Okay, bye.